There is one warning about the build process. Before you build, your current directory must be in the same location as your Simulink model. Like this. Because if you're not in the same directory as your model and you try to build, you get this error. So if you get this error, the first thing to check is that you are in the correct directory where your Simulink model is. We will now create a new Simulink model for our host PC. First, we go to File, New, and Model. A new Simulink model appears. This time, we don't need to configure our model to use Rapid STM32 target because this model will be running on the host PC. So let's just save as ADC host PC demo and save. Next, we will open up the Simulink library browser. Go to Rapid STM32 block set and add on modules. Find the HID receive block, drag and drop it into all model. Now we can configure this block by double click on it. Because we are receiving two single precision data type, we just type in single twice. And because we are sampling at 100 Hz sampling rate, so we set the sample time to be 10 milliseconds. Click OK. Let's save that. And suppose we would like to convert measured temperature in volts to Celsius. We just use the convert on board in 16 volts to temp Celsius from the on-chip peripheral block there. And suppose we want to display this temperature as numerical values. So we just go to standard Simulink block and Sings and drag the display in here. Suppose we want to plot the potentiometer voltage as graph, so we use the scope block again from Simulink Sings block set and drag it here. Suppose we want to display the numerical display for the voltage as well. So we have to, but instead of dragging the display from the library browser, there is a shortcut. We can click on the display and drag this block with your right mouse button being kept pressed. Like that, it will just copy the block. Okay, so let's connect the signal line together like that. However, there is some special requirement for displaying the potentiometer voltage using the display block. Because the display block requires input to be of type double precision, but our potentiometer voltage is output as single type, so we need to convert from single precision to double precision, and we can do that using standard Simulink block. Go to signal attributes and data type conversion. double click on data type conversion. We change the output data type to double click OK. Now to create another signal line from here, we just press the right mouse button and keep it pressed and drag to the block. But here we can drag the signal line as normal. There is one useful tip about data type in Simulink, which is very basic and you should become familiar with it. You can right click on your model and select Format Port Data Type. It will display all the data types that is being used in your model so that you can debug your model. Let's save this model for now. We cannot run it yet. We have to set our target to running mode first. So that's what we are going to do next. To put our target in the running mode, all we need to do is change the switch, program switch 1 to the left and press reset button once. Now our target is running. So if I go back to the simulation model for the host PC, update the model once, just ignore the warning for now, and press run. You can see that all the information is displayed and the graph for the measured potentiometer voltage. However, this model will only run for 10 seconds. So if we want it to run much longer, we can change it to infinity by typing in INF save. Now this model will run forever. So let's see what happens. Click run. If I adjust the potentiometer, you can see changes in the voltage from 3.3 volts down to 0 and up again, like so. We can zoom in the plot by clicking on the binocular icon, and I'll try that. Do that again. So this is it for our first program for acquiring real-time data into Matlab or Simulink using the rapid STM32 block set. Thanks for watching. Just a final remark about the performance specification of the block set. At the moment, the maximum real-time data acquisition into Simulink and Matlab is around 400 Hz. And it is possible to perform signal generation from Simulink to control the target, and also to perform hardware in the loop, closed loop simulation. Both settings have maximum update rates of about 200 Hz. These specifications are based on USB HID communication protocol. Faster speed is possible. Both settings of hardware in the loop simulation will be the subject of our next training. For those of you who need further information, please visit www.imagine.com. In there, you can find datasheets for the FiO Evaluation Board and other information. Thank you again for watching.